Whether you're a tech enthusiast, industry professional, or just curious about the future of AI Agents Unleashed will keep you informed and inspired. Buckle up and get ready to unleash the potential of AI.
Okay, so get this. We're diving into AI that writes code, specifically AI that can actually fix bugs. Yeah, we've got this study, and it compares all these different AI agents, like battling it out to see like who's the ultimate bug exterminator.
Yeah, it's like a coding Hunger Games for AI. So we're talking about large language models, LLMs, those things that are trained on just mountains of text data. And researchers are building these LLMs into agents that can like interact with the code, not just understand it.
Wait, hold on. So it's not just AI reading code, like reading a book. It's like having a little AI programmer sitting there in your computer that can fix stuff.
Exactly. And this study that we're looking at today, it uses this benchmark called SWE-bench Lite. And that uses like real bugs from GitHub. So this isn't just some theoretical exercise. It's stuff that could actually help developers, like today.
Oh, okay. Okay. I'm hooked. I'm in. So give me the highlights. Who are the AI all-stars in this study?
Right.
And were there any bugs that even the AIs couldn't crack?
Yeah, so the study looked at 7 different systems. Some were commercial, some were open source. The top performer was this one called Mars Code Agent. It had a success rate of 39.3%.
Whoa, almost 40%. That's pretty impressive. Right?
Nice.
Like imagine 4 out of every 10 bugs that you find are just zapped away
Yeah.
by this AI.
Yeah, it's definitely a good start. But there's definitely a lot of room for improvement. I mean, keep in mind that 132 out of the 300 bugs in this study couldn't be fixed by any of the AI agents.
Wait, what? Over 130 bugs? Stumped all of them? That's wild. So what is it that makes some bugs so hard for these AIs to fix? Is it the type of bug? Or is there something else going on?
Well, that's where it gets really interesting. One of the biggest things they found in this study was the quality of the bug report. Like, even for AI, if you don't have a clear, concise bug report, it's going to struggle.
So it's like if I'm not explaining the bug clearly to the AI, it's like, I don't know, mumbling to a mechanic about some weird sound my car is making. Like they're not going to know where to even start.
Yeah, exactly. They actually analyzed like how the quote-unquote quality of the bug report impacted the success rates. Did the report say what was wrong? Did it say where the problem was? Did it say, what the code was supposed to be doing?
Okay, so very specific details matter, even for AI.
Yeah.
Got it.
So did the study, did they have any examples of this playing out in the results?
Oh, yeah, definitely. Like there's this one case, it was scikit-learn 25747, and the bug report pointed to like so many potential places where the problem could be that the AI just couldn't narrow it down effectively.
So it's like too much information can be just as bad as too little information, even for AI. Huh. Makes sense. I mean, we humans struggle with that too.
Yeah, exactly. And then there's this other case, Django 13660, and there was like a misleading suggestion in the bug report that just sent the AI down completely the wrong path.
Yikes. Okay, so accuracy is key.
Yeah.
That's a good reminder for me. Got to be super specific when I'm reporting bugs, even if it's to an AI. Yeah, for sure. A well-written bug report benefits everybody, whether you're working with AI or a human developer.
Now, okay, back to the AI systems themselves. I know the study looked at 2 main types. There were agent systems and non-agent systems. What's the main difference between these two?
Well, think of the agent systems like the detectives of the coding world. They can actually interact with the code. They can run tests. They gather clues. It's almost like they're investigating a crime scene.
Oh, I like that. So they're actually poking around in the code, trying to figure out what's going on. Okay, and what about the non-agent systems? Are those just sitting back, reading reports?
Yeah, the non-agent systems are more like analysts. They rely on static analysis of the code and whatever information was provided in the bug report to identify the problem.
Interesting. Okay, so it's like having a detective who can go out and investigate versus one who's, just reading reports. Does that mean that, do the agent systems, do those always outperform the non-agent systems?
Not always. So, in this one case, Django 11422, the agent system, it actually got kind of bogged down by all this extra information it gathered while it was running the code. And the simpler non-agent system, just relying on the bug report, was actually able to find the correct fix faster.
Huh. So sometimes a simpler approach wins out. It's like those crime dramas where, like, the veteran detective solves the case just by thinking it through while the rookie is out chasing, all these red herrings.
Exactly. Each approach has its strengths and weaknesses, and this study really highlighted that, there's no, like, one-size-fits-all solution.
So finding the bug is only half the battle, right?
Mm.
I mean, the AI also has to generate the correct fix, and that seems even trickier. What did the study find about that part of the process?
Yeah, you're right. Generating a correct fix is a huge challenge. Even if the AI like pinpoints the problem area, it still has to come up with, the actual code that's going to solve the issue without creating new problems. And some systems use this technique called sampling, which is basically like trying out a bunch of different fixes and picking the one that seems to work best.
So it's like the AI is like brainstorming different solutions and then like A/B testing them or something. That's pretty clever.
Mm.
This study also found something that kind of stood out to me. They said that line level accuracy was super important. What does that mean exactly? And why is it such a big deal?
So line level accuracy means that the AI has to pinpoint like the exact line of code that needs to be changed, not just the general area where the bug might be.
Okay, that makes sense. But why is that so much more important than, just identifying the right file?
So imagine you're editing like a huge document and you need to change a single word. Finding the right paragraph isn't enough. You need to find the exact word to make the change. It's the same thing with code. That line level accuracy, it requires just a much deeper level of understanding.
So the AI isn't just like blindly swapping out chunks of code. It's actually making these precise surgical changes. That's pretty wild.
Yeah.
Now, I got to ask about something that just sounds like super futuristic: bug reproduction. Is that like what it sounds like? The AI actually runs the buggy code?
That's exactly what it is. So by running the code and actually seeing the error happen, the AI can get some extra clues, especially if the bug report is a little vague.
So it's like the AI is like doing its own detective work, running experiments to see how this bug behaves.
Yeah, you got it. And in some cases, this reproduction step was like essential for the AI to find the fix. There's this one case, SIMPI 15346, where the AI, it used a snippet from the bug report to reproduce the bug, and then it did something really clever. As it was running the code, it actually printed out values along the way, and that allowed it to kind of zero in on the source of the problem.
Whoa, so it's like the AI was thinking out loud, showing its work, and that's what helped it crack the case. That is some next level debugging.
Yeah, it really is. But even with these, super clever techniques, there are still limitations to what these AI bug fixing agents can actually do.
Okay, that's what I was wondering. It all sounds amazing, but I'm sure there's still, some kinks to work out. What are some of the challenges and limitations that the study highlighted?
Well, one of the biggest things was the study relied on predefined tests to see if the AI's fix was actually correct.
Ah, okay. So in the real world, those tests, might not exist for every bug, or they might not be perfect at catching every problem.
Exactly. Which means there's this risk that an AI agent could like fix a bug in a way that seems right based on the tests, but actually causes new problems that we don't catch until later.
Oh, okay. That's a little scary. It's like getting your car repaired and finding out later that the mechanic fixed the engine but accidentally messed up the brakes.
Yeah, that's a great analogy. It really highlights the need for like more robust testing methods, especially when we're dealing with AI-generated code.
So we need to be really careful about relying on AI to fix bugs in, really critical systems, at least for now.
Absolutely. We're still in the early stages with this technology, and it's super important to be aware of, the limitations. But even with those limitations, the potential of AI and software development it's undeniable.
Yeah, I'm starting to see that. It's exciting, a little scary, but definitely fascinating. Okay, I think I need a minute to process all of this before we go any further. Okay, wow, my brain is officially buzzing after that first segment. It's just wild to think about AI, actually fixing bugs in code.
Yeah.
But before we go any further, maybe we can kind of recap what we've learned so far about these AI bug fixing agents.
Yeah, good idea. Let's do a quick summary. So first, even though these AI agents are showing like real promise, they're not going to be replacing human developers anytime soon, right? The best one in the study only fixed about 40% of the bugs.
Right, yeah. We're not at the point where we can just like throw all our bugs in an AI and walk away. But 40%, that's still a pretty impressive start. And it's even cooler because like these are real bugs from GitHub, not just made up examples.
Exactly, yeah. That SWE-bench Lite benchmark makes sure that the study's findings are like relevant to the actual challenges that developers are facing every day. And speaking of real-world challenges, I think one of the biggest takeaways is that the quality of the bug report makes a huge difference, even for AI.
Yeah, that was a big aha moment for me. Like a vague bug report or an inaccurate one can just totally throw off even the smartest AI.
Yeah, it's like trying to solve a puzzle, but you're missing, half the pieces. The AI, it needs all the information it can get to really understand the problem and find the right solution.
Right. And we saw some good examples of that in the study, right? Like those cases where the AI got stuck because the bug report was pointing to like too many possible locations, or it had, these misleading suggestions.
Yeah, exactly. And it's a good reminder for all of us, like good communication matters. A well-written bug report is valuable, whether you're working with an AI or a human developer.
Okay, good bug reports, essential. Got it.
Yeah.
Now, what about the different types of AI systems themselves? We talked about agent and non-agent systems. Can you just remind me again the difference in how they work?
Sure. So agent systems, those are like the Sherlock Holmes of bug fixing. They can actively investigate the code, they run tests, gather clues, almost like having an AI developer pair programming with you.
Ooh, yeah, that's a cool way to think about it. So they're really like digging into the code, trying to understand it on a deeper level. And then the non-agent systems, are those more like, I don't know, Watson, just, analyzing the data?
Yeah, that's a great comparison. So the non-agent systems, they're more focused on just analyzing the code in the bug report without actually interacting with the code directly. So they're relying on logic and deduction to identify the problem.
Interesting. So it's almost like a battle between two different problem-solving styles. Does that mean, is one approach inherently better than the other?
Not necessarily. Remember that case, Django 11422, where that simpler non-agent system actually did better than the, fancier agent system. So sometimes a straightforward approach can be more effective.
Right. It's about finding the right tool for the job. But no matter what approach you're using, the challenge doesn't end with finding the bug, right?
Yeah.
The AI still has to come up with a fix that actually works.
Oh, absolutely. And that's where things get really interesting. Generating a correct fix, that takes a deep understanding of the code and the structure and, what it's supposed to be doing. The AI needs to be able to kind of reason about the code, not just blindly manipulate it.
Right. And we were talking about how some systems use that sampling technique, which is basically like trying out a bunch of different fixes to see which one works best.
Exactly. It's almost like running a series of mini experiments, to figure out the optimal solution. And the study highlighted that line level accuracy is super important. That means the AI has to get down to the exact line of code that needs to be changed.
Yeah, it's not enough to just find the right file or even the right function. It's like, I don't know, one of those spot the difference puzzles. The AI needs to see those little details in the code to really find the error.
Exactly. And that level of accuracy, it requires a really sophisticated understanding of the code's syntax and semantics. It's not just about recognizing patterns anymore. It's about really comprehending what the code means.
That's mind-blowing. And then there's that whole thing about bug reproduction, where the AI actually runs the code itself.
Yeah, that's one of the coolest things about this research, actually. By actually running the code and, seeing the error happen, the AI can gather all this extra information that might not be obvious from the bug report alone.
So it's like the AI is doing its own scientific experiments.
Yeah.
Trying to isolate the cause of the bug.
Yeah, exactly. And in some cases, that reproduction step was absolutely crucial for the AI to find the right fix. We talked about that case, SIMPI 15346, where the AI, it was able to pinpoint the problem by printing out values as it ran the code.
Yeah. That was a really neat example. It's like the AI was thinking out loud, showing its work so we can understand, the reasoning process.
Yeah, it really is. And that transparency is essential if we want to build trust in these AI systems. We need to be able to understand how they're coming up with their solutions, not just, blindly accept whatever they spit out.
Right. That makes a lot of sense. But even with all these impressive capabilities, there are still limitations to what these agents can do, right?
Oh, for sure. We talked about how the study relied on those predefined tests to evaluate the AI's fixes. And those tests, well, they might not always be perfect or comprehensive.
Right. So there's a chance that, an AI could make a change that looks good based on the test, but actually introduces new problems that we don't catch right away.
Exactly. And that's a valid concern, especially as we start using these agents to fix bugs in, more complex systems, things that are really critical.
So the potential is huge, but we need to be really cautious about deploying these AI agents without, proper safeguards. So what are some of the things that we need to be thinking about as we move forward with this technology?
Well, I think one key area is developing more robust and comprehensive testing methods. Ways to really evaluate those AI-generated fixes and make sure they don't introduce new problems.
Yeah, that makes sense. We can't just assume the AI is always going to get it right. What else?
I think another thing to think about is, the role of human developers. In this process, AI can be a powerful tool, but it's not a replacement for human expertise and judgment.
So it's not AI versus humans. It's more like AI and humans working together.
Exactly. The most successful approaches are probably going to involve, that collaboration between AI and human developers, each one bringing their own unique strengths to the table.
I like that. It's not about one replacing the other. It's about how do we make them complement each other. So what could that look like in practice?
So imagine a scenario where an AI agent, it identifies a potential bug and even suggests a fix, but then, a human developer comes in and reviews that fix and tests it thoroughly and makes any adjustments if they need to.
So the AI is kind of like a superpowered debugger, but the human developer still has like final say. That seems like a good balance.
Right. The AI can help to automate some of the more, tedious and time-consuming parts of debugging. And then the human developers, they can focus on the more creative and the complex stuff.
That sounds like a win-win. But I imagine there are still a lot of questions about how to do this right, how to integrate AI into the development process effectively.
Oh, absolutely. This is a rapidly evolving field, and there's a ton we still don't know. But this research, it's a good glimpse of what's possible, and that's incredibly exciting.
It is exciting. It feels like we're on the edge of a major shift in how software is developed, and I can't wait to see where it goes from here.
Yeah, me too. And I think the key is to, approach it with a mix of enthusiasm and caution. We have to embrace the potential of AI, but also be aware of the limitations and the potential risks.
Yeah, that's a good point. Finding that sweet spot between, innovation and responsibility.
Exactly. And I think the more we understand about how these AI systems work, the better prepared we'll be to use them, safely and effectively.
Okay, well, we've covered a lot of ground. We've talked about the types of agents, the challenges of actually getting the fixes right, the importance of that reproduction step, the need for really good testing. Is there anything else we need to explore before we wrap up this deep dive? It's pretty mind-blowing to think that we could be this close to having AI that can not just find bugs, but actually fix them. But as exciting as that is, we've also uncovered some potential challenges and risks.
Yeah, for sure. I mean, we definitely need to balance that excitement with a healthy dose of realism. One of the things that really stood out to me from that study was how much they relied on those predefined tests to evaluate whether the AI's fix actually worked.
Yeah, that was a bit of a wake-up call. Ideally, those tests would catch any potential problems, but we know in the real world that's not always how it goes.
Exactly. Which means there's always a chance that the AI could introduce new bugs or unintended consequences while it's trying to fix the original problem. It's like that old saying, the operation was a success, but the patient died.
Okay, that is a little unsettling. It really highlights the need for super robust testing and validation, especially when we're dealing with AI-generated code.
Absolutely. We can't just blindly trust the AI's output. We need to have those really rigorous processes in place to make sure any changes the AI makes are thoroughly vetted and tested before they're, released out into the world.
So it sounds like human developers are still going to be absolutely essential in this new world of AI-assisted coding. It's not about replacing humans with AI. It's about figuring out how to make them work together.
Yeah, I couldn't agree more. I think the most successful approaches are going to involve a real collaboration between human developers and AI. Kind of taking advantage of the best of both worlds. Think of it like a partnership where the AI can do some of the heavy lifting, like identifying those potential bugs and suggesting fixes, but the human developer is still the one who's ultimately responsible for making sure that code is good.
That makes sense. It's like having an AI apprentice working with a master craftsman. The apprentice can learn and assist, but ultimately the master is responsible for the final product.
Yeah, that's a great analogy. And I think as AI continues to evolve, we're going to see this kind of collaboration becoming more and more common. Imagine a world where developers can focus on the creative side of things, the strategic stuff, and AI handles those routine, tedious tasks like bug fixing or code optimization.
Now that sounds like a developer's dream. But how do we actually get there? What do we need to focus on to make that vision a reality?
Well, I think one of the biggest things is we need to improve the AI's ability to really understand and reason about code. Right now, a lot of these AI agents, they're just relying on pattern recognition and statistical analysis. But if we really want them to collaborate with human developers, they need to be able to understand the intent, the logic behind the code, not just the syntax.
So it's not enough for the AI to just read the code. It has to understand what that code is trying to do.
Exactly. It needs to be able to, kind of infer the goals of the programmer, anticipate potential problems, and come up with solutions that are not just correct from a syntax point of view, but also meaningful.
That is a tall order.
Yeah.
It almost sounds like we're talking about teaching AI to think like a programmer.
In a way, yeah. We're trying to give AI those problem-solving skills, that logical reasoning that human developers have. And that's a really tough challenge. It requires not just advances in machine learning, but also a better understanding of how humans think, how we solve problems.
Wow, this is getting really deep. It's fascinating to think about how AI and human psychology intersect in this field.
Yeah, and it shows how interdisciplinary this whole area is. To really move forward, we need collaboration, not just between AI and humans, but between computer scientists and psychologists and linguists and maybe even philosophers.
Sounds like it's going to take a village to shape the future of software development. But even with all those challenges, it's hard not to get excited about the possibility.
I agree. Imagine a world where software is developed faster, with fewer bugs, and with way more creativity, more innovation. That's the promise of AI in software development. And it's a promise worth pursuing.
Well said. This deep dive has definitely given me a whole new perspective on what AI can bring to the table, and a lot to think about.
That's fantastic. And remember, the future of software, it's not set in stone. It's up to all of us to shape it in a way that's beneficial and responsible.
Couldn't agree more. So to all of you listening, stay curious, stay informed, and stay engaged in the conversation about AI and how it's changing the world around us.
And until next time, keep on diving deep.